Hello, welcome to everyone in this video. This is the part 4 of the solution on the paper Electricity and Magnetism, that is CC3 paper on the year 2023 under Physics Honours, University of Calcutta. You can see this is the question paper. This is question number 1 which discussed in part 1, then question number 2, 3 discussed in part 2, then question number 4, 5 discussed in part 3, and this is the part 4 in which we want to discuss question number 6 and question number 7. So let's start. First question says compare two properties of diamagnetic, paramagnetic, ferromagnetic material. Diamagnetic material means if there is if you consider this is a electric field, and in the diamagnetic material the magnetic field, not pole south pole, magnetic field is slightly deflect by this material, For paramagnetic, this is magnetic field is slightly attract by this material, and for ferromagnetic material this is all attracted by this material. Okay, there is some slight difference, but for ferromagnetic all are coming through this material. So this is the basic difference, right? So permeability is little less than unity. This is little greater than unity, and this is very much greater than to unity. Susceptibility is little less than 0. This is greater than 0. This is very much greater than 0. Example: copper, silver, gold. This is lithium, tantalum, palladium, and this is iron, nickel, cobalt. And this is the basic difference, right? Next, deduce the relationship between magnetization capital M and the magnetization current density Jm. Suppose this is a material, for this volume there is a field point, this is source point. The vector potential of a single dipole moment M is given by this one. This is the vector potential for a single dipole moment in this region. For this region, here is the dipole moment present, here is the dipole moment present here, and for that, at that point P point, you need to find out the vector potential. So vector potential at that point, at point given by this, at point P, right? So at point P the vector potential will be like that. Volume element d tau prime carries a dipole moment m d tau prime, so the total vector potential will be like that. This is the total vector potential. Okay, we have vector identity. We know the vector identity get prime equals to 1 by r equals to r cap by r square. So this will gives you this relation, and this vector identity gives you these two term. Here you can see this volume integration close into the surface integration. This is the volume integration, this is the surface integration. So there is two term, this is the volume term and this is the surface term. So this can be equivalent to this one. This is the Jm, this is JdV, like that. So there is a missing of integration symbol here. So there is a missing of integration symbol. I just write down this integration symbol. So there is JdV and KdA, right there. So if you comparing this thing, you will be get the magnetization current density related with the magnetization Jm equal to curl of M, and the second like loop potential of the surface Km equals to M cross N cross. Next question says establish Faraday's law of electromagnetic induction in differential form. According to the Faraday's law of electromagnetic induction, we know this epsilon, this is the induced EMF, is E dot dl, that is the line integration of electric field, equal to minus d phi dt. This is the flux change, magnetic flux change, right? Negative sign indicate the energy consumption according to Lenz's law. So epsilon equals to this one. If you change this into this form, this flux equals to d phi dt, right? You know the flux equals to d phi, flux equals to, flux equal to B dot A. Here we put d phi dt in this form, right? Del B del T dot dA. And this change into Stokes theorem. By Stokes theorem, if you change in the line integration into the surface integration, this line integration change into surface integration. If you compare these two things, you will be obtain this differential form of Faraday's law of electromagnetic induction, that is the curl of E equals to minus del B del T. Next question says derive the equation of continuity from the principle of conservation of charge. You know the current equals to J ds. This I is current, J is the volume current density. J is the volume current density. Is the current density. This is the volume current density, and rho is the volume charge density. Okay. So volume current density and Q is the rho d tau. Tau is the elementary volume and ds is the small area. Hence, by charge conservation, you can see the current produced due to loss of the electric charge here. So loss means negative. Okay. So the basic conservation of charge conservation, you can say the charge conservation say current is equals to loss rate of charge. That is, the loss rate of charge is the current. So this can be written as I equals to minus dq dt. Okay. So I is j dot ds and dq dt of q is rho d tau. So this can be written as in the volume integration divergence by Gauss divergence theorem by Gauss divergence theorem. You can write this by Gauss divergence theorem. You can write this, and this is del rho del t. So if you adding these two things, finally you get the equation of continuity. Right. Go to the next one. The equivalent inductance of two inductors are 2.4 millihenry when connected in parallel and 10 millihenry when connected in series. Determine the difference between their inductance. So if you consider the inductance of two inductors are L1 and L2, then in series combination they are connected directly and the equivalent inductance will be L1 plus L2. So L1 plus L2 is 10 millihenry, and if you take the parallel combination, there will be product by sum that is 1 by LP equals to 1 by L1 plus 1 by L2. So this value is 2.4 and this is 10 millihenry. So you need to solve this L1 and L2. Just put L1 plus N2 is 10 here. So if you multiply 24 and L2 is nothing but 10 minus L1. So taking the binomial expansion quadratic equation, this is solving this one, you will be get L1 6 or 4. When L1 6, L2 4, when L1 4, L2 6. So difference of this inductance will be 2 millihenry. I think clear about the solution. Next question says an LCR series circuit connected in a source of sinusoidal EMF electromotive force of angular frequency omega and peak value V naught. So the potential will be V equals to V naught sin omega t. Find the current in the circuit. For that we take this LCR, the potential across L is VL, potential across C is VC, potential across R is VR. So the summation of this string equal to V according to Kirchhoff voltage law, KVL, Kirchhoff's voltage law gives you the product, the sum of these two things. So VL is nothing but L di dt, VC equals to Q by C, and this is IR. So in the Q form, I equals to dq dt, I equals to dq dt. So di dt is d2q dt square. If you consider q equals to q naught sin omega t plus phi, so dq dt is like that, and second derivative. Put this thing in this equation, you will be obtain this expression. Common this omega q naught, and this will be formed in this one. Now take this r equals to j square theta, and this is z sin theta. So this gives you the general formula. And after that, if you comparing these two things, here you can see z is like that, and this will be 0. circuit, the resultant impedance of the circuit, what will be the L gives you the omega L, and this is in the parallel combination, you know, 1 by Z equals to 1 by R1 plus 1 by R2 like that. So 1 by R plus J omega L and 1 by J omega C gives you J omega C, right? So if you eliminate the complex conjugate operation, if you product R minus J omega L in up and down, you will be get this one, and separate out G component and this one. So the magnitude will be like that, 1 by this one. Okay, so I think clear about the value of impedance of the circuit. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact details and this is my YouTube channel details. So we'll meet in the next video. Thank you.